So the big picture for this lesson is infinite geometric series and their sums. So here I have two infinite geometric series. The first one has the rule 2 times 2 to the n minus 1 power. And you can see the first terms in the table. The a sub n increases multiplying by 2 each time, which you would expect, and the terms are increasing. Second one, 2 times 1/2 to the n minus 1 power. This time the first term is 2, but the terms are being multiplied by 1/2 each time, so the terms are getting smaller and smaller and approaching 0. This one has a sum. This one has no sum. The reason being is if you're adding a sequence of numbers that is infinitely long, the only way you'll get a sum is if the numbers are approaching 0. If you're adding an infinite sequence and the terms are increasing in value, you're never going to get a sum because the number is just going to keep getting greater and greater. But if the numbers approach 0, you will eventually get a sum. So there's a formula for that. For infinite geometric series, here's how you find the sum. The sum of all the n terms equals the first term divided by 1 minus the ratio. So just for an example, the first term is 2, 1 minus 1/2, because 1/2 is the ratio. That equals 2 divided by 1 minus 1/2 is 1/2. 2 divided by 1/2 is the same as 2 times 2 over 1. Well, that's simply 2 times 2, which is 4. So the sum of this infinite geometric series right here is 4. And this only works if you have a ratio between -1 and 1. So an interesting application of this is writing repeated decimals as fractions. Say you have the repeated decimal 0.555 ... Well, you can write this as a sequence. So your first term here is 0.5, and your ratio is 1/10, because each term is being multiplied by 1/10. So then you can use this sum formula to figure out what the fraction form is. So the first term is 0.5, and you're dividing by 1 minus 1/10. Or you could put 0.1. So this is the same thing as 0.5 divided by 0.9, and that is 5/9. So there you have it in fraction form, 0.555 repeating. So that's an interesting application, and that's the big picture for this lesson.